All right, perfect. Well, let's get started then. Thanks so much, everyone, for tuning in. Before I get started, just to as a brief introduction about myself, before founding Keebo, I spent a decade and a half of my career at the intersection of machine learning / artificial intelligence and database systems. So some of the work I've done with my PhD students and industry collaborators is now running on millions of MySQL servers, but also did some work on analytical databases. And again, some of it was open source and some of it we commercialized and got acquired. But today's talk is mostly about data learning, which is a new concept that one of my PhD students and I came up with and decided to turn it into a company called Keebo. And we have several research publications and patents about the material that I'll be sharing with you in today's talk. But to start, let me tell you about a company called Hyperscience, which is a SaaS platform for intelligent document processing. So they're only about 250 employees, but they've seen a 4x growth in their Snowflake usage just over the last year, and they still need to onboard additional users and applications to their Snowflake. The problem is they don't have enough engineers to constantly optimize their workload, and they cannot keep up with their Snowflake costs either. Well, it turns out they're not alone. There are many other companies with this same problem. In fact, the main trend we're seeing today is that data clouds like Snowflake or BigQuery or Amazon Redshift are seeing massive adoption at a really rapid rate. And that's because what they've done is they've done a great job of reducing the adoption barrier and allowing for innovation to happen very quickly, especially along the edges of an organization. But that has come with some side effects. There are now dramatically more users and applications, a lot more complex data pipelines as a result, and as a result of that, data teams are now overwhelmed, and they're not even enough data ops engineers. They're not even enough data ops engineers out there to hire, even if you had the money for it. And finally, infra costs themselves are also going through the roof. So in essence, what we're seeing is that data clouds have turned a CapEx problem into an OpEx problem. In other words, they have lowered the adoption barrier, but they've actually increased the operational barrier, the operational costs. So here's why you should listen to the rest of this webinar. Using AI, the AI that Keebo provides, the Hyperscience story I told you about earlier had a happy ending. They were able to reduce their cloud data warehousing costs significantly while onboarding additional applications and users, and do so without negatively impacting performance. So what is Keebo and how does it do that with AI? We've built a platform that learns from how users and applications interact with their data and then uses that to automate a lot of tedious data ops tasks. Later, I will tell you how it works, but from a high level, it does three things. It significantly reduces the time customers have to spend on data ops. It also improves performance and drastically reduces the infra cost. By doing this, essentially what Keebo is doing is Keebo is significantly reducing the OpEx barriers for customers. Our vision is to automate many different types of tasks with our data learning platform, but what we currently have available on the market is our automated warehouse optimization and automated query acceleration apps. And the rest of this presentation, I'm just going to focus on those two apps. Now, before I dive into technical details about how we actually do data learning, how you can use AI and all of that, as someone who spent a lot of time on using AI to solve real world problems, let me just talk through some of the ideal criteria that you want to check, that if you can check, it will make it a lot easier to get buy-in from your data teams or business decision makers whenever you're thinking about adopting an AI-based solution. So the first thing to look for is to eliminate any adoption barriers. What this means in a nutshell is that ideally you want a solution that doesn't have any downsides. For example, minimal implementation effort, minimal maintenance overhead, and ideally what I call even a no-brainer pricing. For example, if the goal is to use AI to reduce your cost, then if there's no savings, there shouldn't be any charges, right? The second thing you want to keep in mind is that every customer, every workload and application is going to be unique. So instead of making assumptions or decisions on behalf of the user or the customer, you want to empower users to express their own business requirements. The third criteria you want to think about here is what are the solution you're thinking of adopting and implementing is actually automated, or is it just a recommendation engine? Just to give you an example, at Keebo, we've made a very intentional decision to never become a recommendation engine for a number of reasons. First of all, tuning advisors and recommendation tools have had very little success in our industry. Second of all, a recommendation means you need a human expert to confirm it, to validate it and approve it. But if the human could actually analyze millions of queries and parameters, which is very common in a cloud data warehouse, then they wouldn't need a tool in the first place. Finally, there is actually no static configuration that will be optimal because workloads are constantly changing. So that's why, it's really important for you to know whether you're going for here's a bunch of static recommendation you can apply versus something that's actually automated and fully autonomous. The next thing, if you want wide adoption, is to really protect performance, right? Like to the extent that you can, you want to protect performance to make sure whatever else you do, whether you're saving cost or saving time, it doesn't come at the cost of negatively impacting your users, the performance your users getting out of their data system. The next thing is you want to make sure that you're not making a priori assumptions, right? About the workload, because some workloads are recurring, some are not, and you just never know what to expect. Something that might be a very predictable workload might suddenly change, right? So you just want to let the workload speak for itself, and let the models or the AI learn on the fly instead of assuming certain things from the outset. Finally, remember that data warehousing, cloud data warehousing, or data warehouses in general hold some of the most sensitive data in any enterprise, right? So customers are naturally going to be reluctant to, your business decision makers or your users are going to be, or customers are going to be very reluctant to grant you access to some of that sensitive data, right? So you want to really think about the privacy and security aspect of it. So for example, at Keebo, again, we made a very intentional decision that not only do we not store any of the customer's data for security purposes, we don't even actually see it. So we define views that only give us access to metadata. So nothing sensitive would ever be used for our training. So those are some of the criteria that you may not be able to get all of them whenever you think about adopting AI, but to the extent you can, those are things to look out for. And these are things that, for example, at Keebo, we really prioritized, and that was one of the main reasons we actually saw a lot of successful adoption in the industry. So next, I'm just going to give you an architectural view of how data learning works. Then we'll talk about using that AI for warehouse optimization and query acceleration. And then finally, I'll show you some empirical results and share some customer anecdotes. But yeah, so just please consider this a roadmap for the next 15 minutes of my presentation. Let's begin with how data learning works. So here's our architecture from 10,000 feet. The users essentially can interact with the system through a web portal. They can express their goals either in terms of high-level cost performance trade-offs. For example, I want to prioritize performance or be balanced or go for the lowest cost. But they can also dictate, get a lot more granular and dictate their specific SLA or requirements for different times of day or days of week, and exactly choose what kinds of optimizations they want to allow or disallow at any time. So the portal also actually allows users to monitor cost, performance, and everything else that's happening within, with the optimizations. So ensure the user is always in full control, and the user also has full visibility. Now, the next component is that I want to cover is this monitoring piece, right? Which pulls the performance telemetry data that we're going to be using for training in our data learning. This telemetry data is actually vendor specific. For example, if you're using Snowflake, Keebo would pull 76 different fields, which provide detailed statistics about things like number of queries, how long each query took, how long those queries spent in queuing versus actual execution, how many bytes were scanned, how many of those bytes were remote versus local, what was the type of the query. We even hashed the query text and the query username and the query template for additional security, but we also look for patterns like how many credits were used and things of that sort. So this telemetry data is just constantly pulled into our data learning module for training, for training a model that or an agent that can actually optimize the customer's environment, whereas for optimizing their warehouse or optimizing their queries. So one of the approaches we've invested in at Keebo is actually deep reinforcement learning. So for those of you who are not familiar with reinforcement learning, it's essentially a framework in machine learning that allows you to train an agent that to allow an agent to sort of take actions, and then depending on whether those actions have a positive or negative impact on your environment, then you keep rewarding or penalizing that agent so that it can take better actions every time. Now, so what is an action in our context? So it really depends on the use case, right? So it depends on what's the problem we're trying to solve. For example, if we're trying to optimize a warehouse, then the action could be, adding a cluster, removing a cluster, increasing the size of a cluster, reducing it, scaling up, scaling down, optimizing your memory, tuning various parameters and whatnot. If it's basically you're trying to sort of do schema level optimization, the action could be to change the clustering key from X to Y. If it's about query acceleration, the action space would be, hey, summarize this unit of computation, or pre-compute this thing over here, create a sample of this, or rewrite this query, don't rewrite this query, things of that sort. So those are some of the actions that you can define when you're using reinforcement learning in general, and those are some of the formulations that we rely on. So at Keebo, one of the approaches we've actually invested in is, as I mentioned earlier, is deep reinforcement learning. In particular, we use a specific framework called Q-learning, and we've made that choice for a number of reasons. First of all, Q-learning is a form of what's called model-free reinforcement learning, which is really appropriate in our scenario, because in a data warehouse, we really don't know how the system is going to evolve. So we don't have a model of that. In database systems in general, you don't really know what the reward structure is before exploring and trying things out. For example, how do you know what's going to happen if I go from a large warehouse to a medium warehouse? Is this query's latency going to double? Is it going to triple? Is it going to stay pretty much the same? You don't know that a priori, so you need to learn that, right? The second reason, so it's Q-free. We've picked Q-learning because it's model-free. But the second reason we've actually gone with Q-learning is that it's what's called the off-policy. It's an off-policy framework, which basically means the model can learn a lot faster, even from suboptimal actions. So you get actually faster convergence. So this way, so the way this equation actually works here is, the agent takes an action at step T or time T, takes some action A, and then receives some actual feedback from the environment, right? Now the key is, what's that reward? Sorry, the animations are a little bit lagging here. So the reward that we use actually a weighted function of various parameters depending on the user's preference. So it could be a function of, for example, the query latency, the queue time, the cost of that warehouse running, all of that, and then the weights and which parameters you combine depends on the trade-off that the user has expressed to us. And then depending on the reward that we basically receive from the environment, we update the Q value, and this process repeats until this agent actually learns and is able to maximize the reward. So there's another parameter here that we can actually take advantage of, is that we also have a learning rate. This alpha parameter is a learning rate, and that's actually something that allows us to decide the trade-off between exploration versus exploitation, right? In other words, we can learn the model, explore new actions so they can learn about the environment more. And as it learns more, then instead of doing more exploration, it starts exploiting that learning, that knowledge, so it can rely on its knowledge more and more over time, right? So that's a parameter alpha between 0 and 1. that allows us to sort of have fine-grained control over that. All right, so that's the high-level idea of how you can sort of how data learning works, or how you can, for example, use reinforcement learning for data learning. And the output of this is going to be some warehouse-specific or workload-specific models. So, for example, we train some models for warehouse optimization, some models for query acceleration, and so on. So before I talk about how those specific models work, I'm going to actually dive a bit deeper into how you can train models for warehouse optimization or query acceleration in a bit more detail. But before I do that, one of the cool things about that's worth pointing out here is actually that with data learning, just like how it goes with humans, the way I think about this is like, humans learn, right? So we actually call our model at the Keebo, we call it the robot dog, because it actually gets smarter over time. The reason is that the longer the models are in use, the more they learn about your specific workload and queries, and the more they can adapt. And the more they learn, the more effective their optimizations. So let's dive a bit deeper into how we sort of train a robot dog or data learning to do, for example, warehouse optimization. So as I mentioned, some of the actions you can take, the action space when you're trying to do warehouse optimization are things like adding or removing clusters, upsizing or downsizing, and so on. But here, the example I've picked for this presentation is a pretty simple problem, which is like, how do you optimize your memory, right? So the problem is very clear. A lot of these cloud data warehouses, the pricing model is pay as you go, right? So the more you use, the more you pay. So now the question is, should you suspend the warehouse to save money? So if, in other words, when there's no queries currently running, do you keep the warehouse running or do you suspend it? Because if you don't suspend it, you're just paying the data warehouse pretty much just for running it. There's no queries in there, right? So do you want to save money by suspending it? But then if you suspend it, you're going to lose the cache, which means future queries that may arrive will take much longer because now they have to read data off of cold storage. So a simple solution here would be to set a timeout, which is what actually 99% of users do. For example, they say for things like suspend the warehouse if there hasn't been any queries for at least 5 minutes. But it turns out that that can actually be a pretty bad strategy. For example, the optimal time to suspend the warehouse might be after 60 seconds during a certain times of the day, and it might be 10 minutes during other times of the day. It all depends on the likelihood of the next query arriving after T seconds and how much it actually impacts the performance of those future queries. So now the question is, how can you use data learning to make optimal decisions all the time? So let's say that you have a warehouse W, you can model this problem as saying, okay, U sub W is the unit cost of that warehouse. For example, if you're using an X large warehouse, this is how much I have to pay for per second or per minute or per hour for that particular warehouse. Let's say D is a variable that shows the slowdown of future queries due to cache loss, which is a result of suspending a warehouse early. Let's say you call 1 minus delta T to be the probability of seeing no queries in the next T seconds. So delta T being the probability of seeing at least one query in the next T seconds, then 1 minus delta T would be the probability of seeing no queries. Then you can sort of say that the expected savings, if we suspend right now, would be the unit cost of that warehouse time T seconds time the probability of not seeing any queries. So we actually suspend the warehouse. We can suspend the warehouse if that expected saving, which is this quantity over here, minus the slowdown times the unit cost is greater than some epsilon. At epsilon is the confidence interval, right? If that's more than a certain probability, then you suspend now. Otherwise, you keep the warehouse running. Now the question is, how do you come up with these? How do you estimate these values? Well, you can actually learn this from data. So this is where machine learning can come in. You can actually learn and estimate D and this probability in real time based on the patterns you've seen in the past from your workload. So hopefully one of the things you can already appreciate here is, and obviously that epsilon I forgot to mention, that's also something that depends on the user's risk tolerance, how much they're willing to sort of take a risk with performance versus slowdown, performance slowdown versus savings, right? But you can see even a simple problem like should I suspend my warehouse and when, it actually has a very beautiful mathematical representation, and because there's no way a human can keep solving and estimating these attributes and solving this equation in real time, most of the time 99% of users just pick a static value, which means they leave a lot of performance on the table. They also leave a lot of savings and money on the table. But you don't have to actually. If you leverage AI, you can really automate this stuff pretty easily, and that's exactly what our robot dog at Keebo does for our customers. So then the next component of the system is the actuator, right? Once that agent decides what to do with the warehouse, then it's the actuator that goes and performs that change on behalf of the customer in real time. And then, as I said, we monitor the warehouse and the workload in real time. The models adjust, in case there's a slowdown, there's queuing, or there's a sudden spike in the workload, the models respond to it in real time. There's also a cost model, which I think is also worth mentioning here, which is pretty different than traditional cost models that database systems have, right? In a traditional database, the cost model's goal is to sort of decide what's the right query plan. So that's not what we're talking about here. That's what's still done by the data warehouse. But the cost model we're talking about in Keebo is we actually have a warehouse cost model, which is a vendor-specific model because the pricing model for each cloud data warehousing vendor is actually different. So we have a vendor-specific warehouse cost model, and the goal is to really just estimate savings and guide the decisions of the agent, the robot dog, right? So how do we actually estimate the cost of a warehouse? I'm going to explain through a simple example. Let's say that Keebo decides to downsize an X large warehouse to large for 12 minutes. Then we actually estimate the savings that are a result of that action as 12 divided by 60 times the hourly or the unit cost of running an X large warehouse minus the large warehouse. So the difference between the unit cost of those two warehouses. But you have to also account for the fact that on a large warehouse, some of the queries might have slowed down. So this is, for example, how you can estimate the savings if you take a certain action on a warehouse. So how do you actually estimate these parameters? You can actually use what we call a what-if analysis and then learn the query slowdown using machine learning based on historical data. Once you have a reasonably accurate warehouse cost model in place, then you can do some really exciting things. First of all, as I mentioned, you can guide your robot dog or your AI solution to make much better decisions in terms of optimizing your workload, optimizing for cost versus performance trade-offs. But you can also actually do what I call value-based pricing. So, for example, at Keebo, the way we price this is that we actually estimate the savings for the customer, and then we basically show them that, hey, this is what they would have, for example, spent without Keebo's robot dog. And this dark blue is, this total bar is how much they would have spent if they didn't have those optimizations in place. This dark blue is what they ended up actually using. So a direct savings of using Keebo's robot dog or AI is this light blue. And then the customer just gets charged a fraction of the savings, right? So you can see why this is a pretty interesting pricing model to the customer and appealing from their perspective, because essentially the robot dog is making its own, making money on its own automatically and just keeping a small portion and passing on the rest of it to the user, the customer. So things like this really align the incentives of a solution like Keebo with the customers, but also because the more successful the customer is, the more successful we are. But it also helps with much wider adoption because it essentially completely eliminates the risk from the customer's perspective. So let's actually continue on and talk about the query acceleration example, right? So the goal of query acceleration is to solve one of the oldest problems in the industry, which is like slow dashboards. Like if you're using a BI solution, whether it's Tableau, Power BI, Looker, Sisense, what have you, It's very common for dashboards to take a long time to load, which has a very negative impact on the end user, especially if you're dealing with external facing dashboards and customer facing dashboards. But it also has implications for the data teams, because when those dashboards are slow, people are complaining. And when they're complaining, they have to spend a lot of time fixing the slow dashboard problem. And there's a bunch of solutions for it. Obviously, as I alluded to it, manually optimizing those queries one at a time is one particular solution. That's an endless exercise. Essentially, it takes a lot of time to manually optimize queries one at a time, and you speed up a dashboard. Tomorrow the schema changes, someone adds a new tile, a new dashboards, and then you have to start over that exercise. The next solution is just spending more money, essentially throwing more money at the problem. If you're using a medium warehouse, then double it or quadruple it. That's not a very sustainable solution usually, because to pay twice to get a 2x speed up is not usually going to cut it for a lot of companies. Like if your dashboard is loading, and it takes like 2 minutes for the dashboard to load, then are you willing to pay twice just to bring it down to 1 minute? Right? Usually when you're looking for acceleration, you want something that's super linear. You're not just looking for a 2x or 4x speed up. So the cost can become pretty prohibitive. The next alternative is sometimes BI teams try to just restrict the dashboards from having too many tiles. So like simplify those things and just cut back really on how many tiles you have on a dashboard, how rich of a dashboard you're building and whatnot. And there's a limit to it as well. Like at the end of the day, you don't want to defeat the purpose. People create fancy dashboards to, empower users or data analysts or business decision makers to see a high level, quick overview of the whole business and make insightful, meaningful decisions, right? So you can't just break that dashboard into 5 different dashboards either. Another solution that's also very common, but again, not so ideal, is to just rely on stale data, right? For example, if you're using Tableau, you might want to just look at an extract of that data that's like a day old or something. I think they call it imports with Power BI, PDTs if you're using Looker, and then you can say, hey, you know what, just pull this data every hour, every 24 hours. So that data is cached in the BI tool, and you're essentially looking at stale data, which has its own downsides. Stale data means you might have actually data inconsistencies. You're not looking at the latest data, et cetera, et cetera. But those are some of the solutions. These are old solutions to a very important and old problem. So what I'm going to actually talk to you about today is how you can actually use data learning again to solve this problem without any of those downsides that come with the other solutions I talked about earlier on the previous slide. So in Keebo, with Keebo, we can actually solve for slow BI dashboard problem in a very similar way. We actually we train models and build smart models. So there's 3 steps involved here. The first thing is you basically, as you can see in this animation, all the user has to do, or the data team, is to just change the connection string so that the queries, the BI tool sends the queries to the Keebo server or the Keebo service that's running, right? Like you don't have to change your driver, you don't have to change your dashboards or queries, anything like this. None of that. Like you just basically a single line change and you put in Keebo in the query path, right? So once that initial connection is done, Keebo exposes the same wire protocol as the underlying data warehouse. So now your BI tool still thinks they're connecting to your data warehouse still thinks the connection is coming directly from the BI dashboard, but the reality is you've put Keebo in the query path, and the next thing that happens is now Keebo starts automatically learning from your query pattern and your schema and data distribution, and starts building a set of what we call smart models to summarize that data. And then once that's done, then it basically starts automatically rewriting the slow queries and using those smart models. So how does it decide when to rewrite a query, how to rewrite a query? Keebo essentially asks 2 questions. Number 1 is it tries to predict the likelihood of that query taking, let's say, more than 2 seconds. And then the second question is, okay, given the smart models that it has already created, does it have one or multiple smart models that can answer that question, that query? Can that query be rewritten to use those compact smart models instead of the giant base tables? If the answer to both questions is yes, meaning Keebo determines it is going to be a slow query and it does have smart models that can speed it up, then rewrites that query and then sends that rewritten query to the customer's own data warehouse. So the beauty of this is that this is all automated end to end. And as the data, underlying data changes, Keebo keeps, automatically detects those changes and updates those smart models, and it also automatically rewrites those queries, but does it on the fly. So when the user goes back to their dashboard, they still see the original queries, right? So they don't get confused. But also, in both cases, it's the customer's own data warehouse that's running this query, except that with data learning in place, with AI in place, your data warehouse is now executing or running a significantly more efficient version of your original query. So a deployment model, again, is designed to allow for wide adoption and easy adoption. So it doesn't come with any side effects for the user. All communications are encrypted. In transit, the data is never leaving the customer's own data warehouse. The data is always, even smart models are actually stored inside the customer's own data warehouse for additional security and peace of mind, and they're tucked away under a separate schema. If a query arrives and Keebo thinks that query is fast enough to begin with, the user can define that threshold, obviously. If the query is fast or Keebo doesn't have the right models to speed it up, it doesn't do any harm. It just lets that query, bypasses that query unmodified. So, you either get the original performance or you get a significantly better performance for a large fraction of your slow queries. So one of the most common questions I usually get asked, that's why I just added a slide about this, is how is it different than materialized views? And the short answer is materialized views is a special case of smart models. A smart model could be a materialized view, could be a data summary, it could be a sample, it could be a partition, it could be a pre-computed unit of data and things of that sort. But also smart models are fully automated end-to-end. As I mentioned earlier, basically Keebo automatically decides what's the minimum number of optimal smart models that can speed up the largest subset of your slow queries given whatever budget you've given it. Automatically builds those models, automatically maintains those models, automatically detects changes to your underlying data, and automatically adapts to changes both in your workload as well as your data, and also automatically detects slow queries and automatically writes those queries, and guarantees that the rewritten query is also equivalent to the original query. Materialized views don't do this automation end-to-end. They still involve a lot of hand-holding and effort and involvement from the data team. So hopefully what I've been able to convince you so far is that there's a lot of really cool things you can do with AI. There's a lot of really important problems that data teams spend significant time and effort on, but you can actually leverage AI to solve those things. So we actually, as I mentioned earlier, we have a much more detailed report. It's a peer-reviewed paper published at ECM SIGMOD. I encourage you to go look at. But I'm just going to go over a couple of experimental results. Obviously, the ultimate result is whether, the ultimate testimony of whether something works is whether customers are happy about it. So we've been, we're seeing a rapidly growing customer base and user base that's leveraging our AI to really free up their time to work on other things that are more important to their business. But we also have a number of benchmark and experimental results that we report in the paper. For example, you can, some of the questions that you might be asking is like, okay, how long does it take for the models to learn and start delivering value? How accurate are these models when they estimate the cost or the performance? What's the overhead of training these things? How effective are these models? You can find very detailed, these and a bunch of other detailed experiments in our SIGMOD paper. I'll share a link in a second. But here I'm just going to share a couple of quick experiments. For example, what we've actually seen in our experience is that most customers start seeing results within the first 24 hours. So there's always this perception that, oh, AI takes forever to learn and whatnot. But one of the most interesting things is that because you can pull a lot of historical data, the models start delivering value most of the time within the first 24 hours without negatively impacting performance. another thing that we're basically measured is like, what is the impact or the overhead of applying deep learning on the customer spend? And the answer is it's almost nothing, right? Like compared to the amount of savings you get, that overhead is really negligible. As I said earlier, feel free to go to this URL over here and download the ACM SIGMOD paper. There's a lot of technical details, both about the algorithms, links to the patent, but also, more benchmarking data and things that you might have questions about. So I know we're running out of time here. Just to sort of conclude here, hopefully what I've been able to convince you of is that the value that AI and data learning can bring to your data teams by automating a lot of the tedious tasks, right? First of all, no one likes to do or has the time to do, but even if they like to do them and have the time to do them, actually, to do those tasks, AI is a lot more effective than any human, simply because of the sheer volume of queries and statistics and numbers that someone has to take into account to sort of decide what's the optimal decision. And then these workloads are constantly changing, constantly, running in a cloud environment. So I really encourage you to really think about adopting AI. With that, I'm gonna just go through some of the questions you've put in the text box and try to answer a few of them in the next few minutes that we have left here. So the first question is, who's what's the impact of training these models? Who's paying for training these models? That's true. Machine learning models have an overhead for training, but compared to the value that they bring, is that cost is actually negligible. But also those costs are incurred on Keebo's own servers. So the training is actually not charged to the customer. Those are all a hosted service. They're not running on a customer Snowflake. They're not going to slow anything else down. Keebo's paying for all that training, and none of the customer data ever leaves the customer service. It's just the metadata goes to the Keebo servers. The training is done, and then the model gets applied to the customer's warehouse. The next question is, how is this different than other companies who claim to do warehouse optimization? So the honest answer is actually no one else is on the market is able to do automated warehouse optimization. So a lot of, unfortunately, other vendors that sort of claim we're doing automated warehouse optimization, what they're doing is really just like giving you a bunch of advice, quote unquote, or fancy visualization or recommendations. But at the end of the day, you have to decide whether that recommendation is a good one or not, right? So if you apply a recommendation and then 2 a.m., 2:30 a.m., there's a spike in your workload and things slow down, then you have no one to blame, because they're basically just giving you a recommendation. You have to own that decision. Likewise, if suddenly in the middle of the night there's an opportunity for significant savings, you're not there to change the recommendations, right? Because you can't just like make recommendations in real time, expect a human to apply them. So it's usually these recommendations are given every 2 weeks, every week or something like that, right? So you miss out on a lot of real-time optimization and savings opportunities, but also you're really vulnerable to a lot of real-time spikes that can cause slowdown and frustrate your users. So that's one of the main reasons that we intentionally invested in creating a solution that allows the user to override decision, to define a parameter space that they're comfortable doing, but the user doesn't have to. It's able to actually safely run in fully autonomous fashion. The other thing that's different is like our value-based pricing. So instead of just charging, a fixed cost to the customer or a percentage per customer, we just really just charge whatever we save the customer. So if the customer is not saving anything, they don't get charged. The next question is, where are the models stored? So as I mentioned, the models are actually stored inside the customer's own data warehouse for the query acceleration, and they're actually tucked away under a separate schema, like a Keebo schema. And that helps with security because the data is not copied out of the customer's data warehouse, but also because when the customers, like if they log in and they see a bunch of like tables, because these models are just stored as any other innocent looking SQL table, right? So if they look in the schema and see a bunch of confusing tables, they might make mistakes. So they're tucked away under separate schema. The users just focus on getting the right query. The data analysts focus on getting the query right, and don't worry about performance, and let Keebo worry about rewriting that query into a more performant version. Let's take, I'm just going to read one last question here, and happy to take the rest of the questions offline, or someone from the team will reach out to you because we're running out of time. The question is, so how, not sure if I understand this question. How is the, how long does it take before the model starts saving? So as I mentioned, like every workload is different. The percentage of saving is also different. We see customers with like, 80, 90% savings, customers with 10% savings. It just depends on the overall spend of that customer. Depending if a customer is paying $10 million, 10% saving is a lot of money. For another customer, 20% might be a lot of money. But how long it takes, there's most customers I was sharing earlier start seeing results and saving within the first 24 hours, but actually the models keep improving over time as they actually interact more with the environment and they observe more and more data. So they get smart over time, which means the results keep improving over time as well. But usually within the first 24 hours, most customers start seeing values. So I'm gonna stop here because we're going over time. But thank you so much, everyone, for tuning in. Really appreciate your time, and hopefully, you learned something that was worth your while. Thanks so much.